Hey there, calculators. Welcome to another video with me, Mr. Leavenworth. We are going to be talking today in two different parts. This first part is pretty brief. It's about the derivative rule for exponential functions. We've obviously talked about a particular exponential function, e to the x. We're going to talk about if that base number is anything different, like 2 to the x, or 5 to the x, or 1/2 to the x. And so what we are going to do is we are going to take a look at kind of just how this rule that you will probably like better than trying to derive it each time comes about. And so what we are going to do is go about doing it just like this. So we don't know how to take the derivative of a to the x, which is what I have here on the screen, but we can do some fancy algebraic manipulation and check this out. So I am actually going to, and I can do this for free, take the derivative with respect to x of e to the natural log of a to the x. And I can do that, and maybe you remember this from Algebra 2 or Pre-Calc, that e and the natural log are inverse functions. So they're going to cancel each other out, and I will still be left algebraically with a to the x. And what this allows me to do is to take this a step further, and because of our logarithmic rules, I can rewrite e to the natural log of a to the x as e to the x times the natural log of a. And we can do that because we're allowed to move this exponent down in front and have an equivalent expression. And that works really, really well. And what that allows us to do is to rewrite it something like this using the chain rule. Check this out. We can now say that the derivative of a to the x is equal to the derivative of e to the u. We're going to let u stand for this entire expression, times the derivative of u, which is x times the natural log of a. And so we know what the derivative of e to the something is. That is just e to the something. And now we know that the derivative of x times the natural log of a, this is just a constant. So that entire derivative is just ln of a. And so now when we put everything back in, we have e, and instead of u, we have x ln of a times the natural log of a. And what we can do, we're going to make a little more space here, sorry about that. We can kind of reverse this law. So this is equal to e to the natural log of a to the x times ln of a. And our derivative here, we've kind of done some math magic and worked backwards, is a to the x times the natural log of a. And that is our derivative. We can put that up here at the top of the problem, a to the x times the natural log of a. So if the derivative was 5 to the x power, our derivative would be 5 to the x power times the natural log of 5. We're going to take this, this rule and use it for these three problems down here below. And we're going to see how this goes. So we're going to start off very, very basically for letter A here. All right. F of x is 2 to the x, so f prime of x, following our rule, is going to be 2 to the x times the natural log of 2. And that's it. That is all you have to do. There's nothing more to it than that. And there's no simplifying to be had there. Let's talk about letter B. And this gets a little trickier because we don't have just a straight x value here. We have a negative x, which the chain rule will be involved, and that's okay. So we will say f, capital F, prime of x is going to be 3 to the negative x times the natural log of 3, but because our exponent is a function of x, we need to take that derivative, and the derivative of negative x is negative 1. So we are just left with f prime of x is equal to 3 to the negative x power times the natural log of 3. And that is our final answer here. Awesome. And now we're looking at letter C going, oh boy. And this is definitely the most complicated, but we're still going to follow our pattern. We're going to say g prime of x is equal to the base times the x, or to the exponent, all right, times the natural log of 1/2 times the derivative of the exponent because of the chain rule, and that exponent is 2x. So there's a number of different ways we write this out, and the order in which you multiply things doesn't matter. I would probably write 2x times 1/2 to the x squared plus 1 times the natural log of 1/2. And even though this was a more complicated looking problem, it still didn't take us more than 30 seconds, and that's pretty great. This is the first part of the video. This is all it is. It's just this front page. If you have any more questions, make sure you let me know in the comments or let your teacher know in class or anything like that. We will move on to 3.9b in the next video.